All right, here we are doing this next problem. Now, we want to determine the average force exerted by this string pulling this cart. This is so great. Here we go. The average force is going to be the average of these numbers. So that's going to be 0.84 plus 0.85 plus 0.84 plus 0.83 plus 0.85 divided by 1, 2, 3, 4, 5. I think this works out to be 0.83, but let me just double check the numbers. Hi, Olivia. That's Olivia. She's observing that I got 0.84 newtons, but she's not impressed. Now let's get the average work done by this force. So the work is going to be force times the displacement that we go through. So that's going to be 0.84 times 0.4, and that's going to give me 0.366, so 0.37 joules of work. Awesome. Now let's go ahead and graph the square of the speed versus position. And they've already done that for us. So at 0, square of the speed is 0.33. 0.1, my speed is going to be about 0.44. At 0.2 meters, I got 0.73, 0.3. I'm at about 0.88, right about there. At 0.4, I'm at about 1.17, which is about right about here. So let's see if we can draw a best fit line. I'm excited. I hope you're excited. Are you excited? Probably not. There we go. Now let's just go ahead and throw this in there. Oh my goodness, look at that line. Let's see, maybe a little best fit line. Oh, look at that. Try to, try to get a decent, a little bit above, a little bit below. Oh, look at that. Oh, such a good line. Okay, now I'm going to go ahead and try to get some set of numbers here. So we got to get a slope. And here we got to kind of guesstimate. So let me just see. So this looks about, I'm just going to guess here, this looks like it's about 0.258. And right here, I would say this looks like, oh gosh. Honestly, I'm going to use this point, 0.1 and 0.44 and just see what we get. Okay, so we got 0.8 minus 0.44 divided by 0.25 minus 0.1. We're going to get that slope that's going to be 0.36 over 0.15. When we actually get that slope, it's going to end up being about 2 point something. Yeah, about 2.4. By the way, the units rise over run, so that's going to be meters per second squared. Now, that's the best fit line. We just calculated the slope, but now we want to get the acceleration of the cart. So let's be clear. V squared versus x. So do we have a formula that has both of those? This is where you got to use your memory and realize that v squared equals 2a times x plus v naught squared. So this will be our intercept, and our slope is going to be 2a. So we have 2a equals 2.4. That means the acceleration is going to be 1.2 meters per second squared. Let's use a different method to get the work done on the cart. So why don't we do delta KE as the work? That's going to be 1/2 times 0.65 times V final squared, which was 1.17, minus 1/2 times 0.65 times V initial squared. V initial is going to be 0.3. Well, that's V initial squared is going to be 0.3. And so when we actually do this math, this is going to be 0.325 times 1.17 minus 0.3 is going to be 0.87 when we actually work this out. We're going to end up getting about 0.38 joules. So I'm actually not getting much of a discrepancy here. I get about 0.37 versus 0.38. Within sig figs, this is consistent, by the way. So I think we're good. All right, there we go. By the way, if you do have a discrepancy, I'm going to assume that the most probable cause would be something related to friction. Anyway, that is it for this problem. Hope it was helpful, and I will put these videos online.